Okay, our objective in Algebra 1 today is to graph systems of inequalities. So we're going to start out with problem number 1 being solution or not. And we've talked lots about solutions, and that solutions are what makes it true. So our problem is the point 5,3. I want to know if that is a solution to the system 6x plus 2y is greater than 1 and negative 2x minus 3y is greater than 2. To tell if something's a solution or not, we plug it in. 5 gets plugged in for x, 3 gets plugged in for y. So 6 times 5 plus 2 times 3, we want to see if that's greater than 1. So 6 times 5 is 30, 2 times 3 is 6, 30 plus 6 is 36. Is 36 greater than 1? Yes. So I put a check mark. The other equation, negative 2x, or the other inequality, negative 2x minus 3y is greater than 2, would be negative 2 times 5 minus 3 times 3 is greater than 2. Negative 2 times 5 is negative 10, negative 3 times 3 is negative 9, so that makes negative 19. Is negative 19 greater than 2? No. So that means 5,3 is not a solution to this system. In order to be a solution, it has to be true for both of them. Okay, problem number 2. Now we're going to graph a system. We want to graph y is greater than 2x minus 3 and 2x plus 3y is less than 6. So I'm going to sketch a set of axes. And for this first inequality, y is greater than 2x minus 3, I start at negative 3 because that's my b. And I move up 2 and over 1. My slope is 2 because that's what's with the x. So up 2 over 1, up 2 over 1, up 2 over 1. When I connect these dots, I connect it with a dotted line because it's just a greater than sign. And then I shade above the line because it's a greater than sign. Now, for the other inequality, 2x plus 3y is less than 6, I can't graph that the way it is. I have to solve it for y. So I do minus 2x minus 2x. So I get 3y is less than 6 minus 2x. Divide by 3. And y is less than 2 minus 2/3 x. So that when I graph this one, I'm going to do it in a different color. I'm going to start at 2. And my slope, because that's my b, my slope is negative 2/3, so down 2 over 3. Down 2 over 3. When I connect with a dotted line. And my shading this time is below. So this double shaded area, that is my solution set. So solutions are in that double shaded area. So my next question is for you to give me 2 solutions and 2 non-solutions. So for solutions, we look in that double shaded area and we find 2 points that are in there. I'm going to go with 0, 0 and negative 1, 0. There's an infinite number of solutions in there. You just need to pick 2. Non-solutions means everywhere else. So I'm going to go with 3, 0 and 4, 0. So solutions are in the double shaded area, non-solutions are everywhere else. So problem number 3. Y is greater than 3 and 3x minus 2y is greater than 4. To graph this one, sketch a set of axes. For y is greater than 3, anytime it's just y and a number, it's a horizontal line. So I go to where y is 3, and I put a dot, and I draw a horizontal line. My horizontal line is going to be dotted because it's not or equal to. And then we want to shade the greater than, so that's above. So I shade all up here. Now this other inequality, I have to solve it for y like I did on the last one. So minus 3x minus 3x. I get negative 2y greater than 4 minus 3x. When I divide here, I divide by negative 2. And there's a rule you have to remember, that when you divide by a negative, you have to flip that inequality sign. So that flips to a less than sign. That makes negative 2, and that makes positive 3 over 2x. So when I graph, I start at negative 2, because that's my b. My slope is 3 over 2, so up 3 over 2. Up 3 over 2. And again, I connect with a dotted line. And it's a less than sign, so I shade below. And you can see that area right there is the double shaded area, so that's where all my solutions are. Number 4 is going to be the reverse. I'm going to give you the graph, you're going to give me the equation, or inequality, I should say. So if this is my graph, to get my inequalities, I'm going to first look at this vertical line. All vertical lines are in the form x and a number. The number comes from the x-axis right there, so it's 2. Then we look at our shading. Is the shading toward the greater than side or the less than side? In this case, it's shaded toward the greater than side. And it's a solid line, so its x is greater than or equal to 2. For the other line, we're going to put it in y equals mx plus b form. And I always start with my b. My b is where it crosses the y-axis, and it crosses at negative 1. Then I find my m, and I can see I go up 1 and over 1, up 1 and over 1, so my slope is 1. I'm going to put my y. Now my shading is above, so that means it's a greater than sign. And then the line is solid, so greater than or equal to. And you can either write that with the 1 or without the 1. So I'd also accept y is greater than or equal to x minus 1. Your assignment today is page 424, 425, numbers 16 through 25, and 35 through 37.